In this video, we're going to look at empirical formula and molecular formula. Now for empirical formula, it is the simplest whole number ratio of atoms, how they combine to form a compound. It doesn't really show us the actual number of atoms. It just shows us the whole number ratios, how they combine. Now, while the molecular formula is what actually gives us the number of atoms of each kind in the molecule. Alright, so let's look at an example. This question says, an organic compound contains carbon 64.88%, hydrogen 13.51%, and oxygen 21.61%. Calculate the empirical formula and the molecular formula if the compound if the molecular mass is 74 grams. So the first thing that we will do is to write out the contents of that compound. It has carbon, it has hydrogen, it also has oxygen. Now the next step we'll have to do is to divide them through with their respective molar masses. Carbon is 12 because it is diatomic 6. So since it's diatomic, it is 12. Remember, carbon in the question has 64.88%. Hydrogen has 13.51%, while oxygen has 21.61%. So if we are to divide them with their respective molar masses, we'll have 64.88 over 12. Here we'll have 13.51 over 1, and here we'll have 21.61 over 16. Because it's diatomic as well. If we divide here, we're going to get 5.4 approximately. Here will still be 13.51 because we're dividing with 1, while here we'll be getting roughly approximately 1.35. Now the next step is to divide all through with the smallest of the results that we got. The smallest is 1.35, so we say 5.4 over 1.35, here 13.51 over 1.35, here 1.35 over 1.35. Here we'll get 4, here we get 10, here we'll still get 1. So it means carbon is 4, the empirical formula is that carbon is 4 and hydrogen is 10, only 1 oxygen. So this is the empirical formula of that compound. So since the empirical formula is C4, H10 and O, for us to now find the molecular formula, what we need to do is to bring out C is 12, or we'll put it first of all C4, H10, O, and from the question we were told that the molecular mass of that compound is 74. So it means this times N is what gives us 74. So C is 12, so we have 12 times 4. H is 10, we have 1 times 10. Oxygen 16, so it's still 1, so just say 16. All of these give us 74. So this times this 48 plus 10 58 plus 16 74. So we have 74 N give us 74. Therefore N is 74 over 74, which is 1. Therefore the molecular formula is still N is 1. So if N is 1 there, the molecular formula is still C4, H10 and O. The next thing they said is that we can suggest or write down any possible structural formula for this compound. So the possible structural formula is, we can write CH3, CH, branching CH3, then CH2OH. We have 1, 2, 3, and 4, 4 C's. For each, we have 1, 2, 3, plus 3, 6, 7, 10. Oxygen is O. What we mean by this is, we have the first C has 3H, second one has 1 and 2, then this same second one, the branch, it also has another this, so it has here, 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 here. Then we have another C that has this. It is this C that now carries the functional group alcohol. So it means we can name it as let's say 2-methyl, because at the second carbon atom there is methyl. So 2-methyl propan 1-ol. 1-ol. So what it means is that, you may neglect this, just write it together. 2-methyl propan 1-ol. What it means is that at the second carbon atom there is a methyl attached to it. At the first carbon atom there is an alcohol functional group there. So